All right, so to show the solutions for this quadratic, it may be written in the form x equals p plus or minus q root 13, where p and q are positive integers. So your integers are positive and negative whole numbers, so it's just going to be positive whole numbers. So we plug this into the quadratic formula and we solve it. And here's the work for that. And once we get done with that, we end up with 6 plus or minus the square root of 208 over 2. All right, then from there, I simplified 208, and I got it down to 4 times root 13. And then here, from this point, I just broke it up into two fractions and simplified each fraction. And there's my final answer. So x equals p plus or minus q. This is your p value, plus or minus q is root 213. And that's how you'd write your answer, because that's the form that the question's asking for. All right, now part B says hence. So hence means use the information from this to solve this inequality. That's what, anytime you see the word hence, use the previous results to solve this inequality. All right, so we'll do that next on the next slide. Okay. All right, to solve the inequality here, we want to find out where is this quadratic less than or equal to 0, which means we want to find the intervals on the x-axis where the graph is negative. It's below the x-axis. So I took the two roots that we determined in the first part, and I converted them to decimals and placed them on a sign chart. Okay, here's my conversion right here. All right, and then I picked 3 test values for each one of the intervals. So -5, 0, and 11. Then I plugged -5 and into my original equation here and see if I get a positive or a negative number. Okay. So you can just type it in, or what I did was I put it into y equals, and then I'm just going to use the value function. And what's the value when x is -5? The value is positive 12. So in that interval, I know my graph is above the x-axis. Well, since this is an x-intercept, if it's above the x-axis to the left of -4.21, then after it, it's going to be below the x-axis. This is an x-intercept, so when the graph is below the x-axis and passes through an x-intercept, it's going to be above the x-axis. So the interval where my graph is less than or equal to 0 would be between 4, and it would include 4 because of that equal sign. So I put a dot and then a dot at the 10.2, and that's the answer in terms of a number line. Now if we wrote it in set notation, we'd say this is less than or equal to 3 plus 2 root 13, and this is less than or equal to 3 minus 2 root 13. Or in interval notation, okay, I would write bracket 3 minus 2 root 13, comma, 3, whoops, plus 2 root 13. Square bracket. Okay, so either one of these solutions would be fine. You were they were your former kids. Say hi to them.
Oh, hey guys, how are you? You should screwed up in Croax class bad enough.
All right, and then there's our solution once I plugged in those test points. So right here in interval notation. All right, number 6, we're asked to take a quadratic curve that's in general form. It intersects the x-axis at 10, 0 and has a line of symmetry at x equals 5/2. Find the values of b and c, and then hence, or use the answers from A to find the other two coordinates where the curve intersects the coordinate axes. All right, so to find B, I use the formula for the axis of symmetry if an equation was written in general form, which is the opposite of B over 2A. Okay, so that's right here. So to find B. So I plug that in, and I fill in 5/2 for x, that's the axis of symmetry, and then I solve this equation for B. So cross multiply, I get 10 equals -2b, divide both sides by -2, and I get B value is equal to -5. Okay, now I take, to get to the C value, I take that B and I substitute it into my original equation. Now I need, in order for me to get C, I need a point that I can substitute in for x and y. So I use the x-intercept that I was given, 10, 0. Substitute that in, 0 for y, 10 for x, and evaluate it, and then solve it for C, and I get C is -50. So now I have my complete equation here. So I'm going to use the results from the first part to do part B. That's what the word hence tells us. So it says find the other two coordinates where the curve intersects the coordinate axes. Well, since this is in general form, I know that the constant C is the y-intercept, so that was easy. And then to get the other missing x-intercept, I'm going to find the distance from the line of symmetry to the x-intercept that I was given, 10, 0. So the distance between those two x-coordinates is 15/2, or 7.5. So then to get this missing x-intercept, I took 5.5 and subtracted 15/2, which is right here, and I get the other x-intercept is -5.